Hello everyone. I'm Ajit. I'm from Forto. I'm staff engineer. Today I will be showing how we use DLT in our data platform. Before I start, I would like to introduce what does Forto does. This is our motto here. We are building the backbone of global trade to make shipping product as easy as sending emails. I know with the Gen AI stuff, everyone can do or build the products very easily. But in the scope of supply chain, right? Supply chain is very much complicated and complex. You might have heard about getting a shipment from China into Germany, right? Those large vessels carrying shipments. We deal there, so we don't deal with Amazon like stuff where you have a Prime membership and you get the stuff in 1 month. Here it takes time. So the lead time which takes to get the shipment from China to Germany is of 3 months on an average. It can go up to 6 months. If there are disruptions, it can go up to 9 months as well. So the complexities in managing those shipments are very high, and so does the business. I want to introduce Forto's business model. There you see it in a very higher scope, from 10,000 feet. This is not the only thing which Forto does. It's much more complicated, but I just want to introduce. So usually the journey starts from the left side where a customer pays the booking, and the booking in the origin of country. So here it would be Germany or China. So let's take an example. If you want to order a shipment from China, so that's where it will be. A customer places the booking. Customer have suppliers in the China who make the products for them. So this is where you will see the warehouses. And what this Forto does is it arranges all the intermediate components. So there are shipments which originates in the China, lines up in your warehouse, which is in Germany. So you see here, right? So now we have factory here, we have a truck here. So shipments, we pull it from the factory, we put it in the truck, get the custom clear, put it on a ship or a plane, whichever way you like. Then clear another customs in Germany, load it on a truck, deliver to your warehouse. So there are multiple stakeholders which are involved here. So you have to talk to those stakeholders. When I say talk, it could be through API, programming interfaces, sharing Excel file. There are 55 such communication points, which I know. I don't know how many are there else in the Forto, but I know there are 55 ways in which our operation manager talk to the customers, and there they fulfill all this journey. So what is complicated here? So the first thing, which is communication, which we need to talk to each other. The laws for each countries. So China, they are very strict with everything from data stuff to not exposing anything. So they're very strict there. So we have to also fall back on their compliances, make sure that we are not being non-compliant there, or risk of getting blocked by them. Same time, Germany also have tedious process of documentations, right? So we have to be very much cautious on the document sides, provide privacy. This overall stuff is in one flow. Likewise, we have multiple such flow which are tailored to the customer's need, tailored to where the shipment is origin and where the shipment is landing. And overall, this makes Forto the very complicated business. So having said that, from the data perspective, right, we are not very large in the data, but our data is complicated, and so do our services. So we are dealing with someone who have complicated data, have more data quality issues. So we are talking in that perspective. And I will show you how DLT solves that problem, how we have also solved that problem. Moving on, I want to also introduce my team with whom I work in the Forto. We are a very small team, but do very impactful job. That's me over there, Bharat, Sarin, Sonam, the 4 engineers, Dan, who's sitting over there, and Tura, our PO. So before I move, to next slides and show you the architecture part which you would be interested. Know that I joined Forto in 2021, and we have built a lot of good stuff. But when I joined Forto, right, the the scope of business was that it was scaling up, so it was in the startup mode. We were having more and more customers onboarded. Don't forget the Corona stuff, where business boomed. So that was also the point for us. The data which we had was very much complicated, as I said earlier, and that's why it was very essential for us to build values first within the team so that we know exactly what we are solving. So these are the three values which we have built. And the first one is robust data infrastructure, which will be like, we make sure that data is accessible, it's reliable, it's quantified, it's well organized. So we fall back on all the good practices which are there in industries. We have also learned from DLT the way they built the pipeline. So we have also infused a couple of the values from it. The second was automations. We are cloud based, and there's a gap between what you can do on the cloud and what you cannot do it. We also try to automate our repetitive tasks so that it does not bring bottleneck in the future. And also the measurable impact. I know the data is always the cost center in the company, right? We want to show that it's not for us. So we always present with the KPIs. We also see how a return of interest matches with the KPIs or not. So these three values drive us to do innovative stuff. So as I said, when we started, our architecture would look something like this. This is like a monolith architecture, and you'll see we have correctly classified the operational and the non-operational data sources. We use Google Cloud, and BigQuery is our central warehouse. All the heavy job was done by one single tool called Matillion. I don't know how many of you hate Matillion, but I'm the one there. Okay, good to know. Yes, I will share a couple of facts about Matillion as well, but it was the bread and butter for the data team. If it goes down, we had a field team to get it online and execute our ETL stuff. But as you can see, like everything which is possible was done through Matillion. Sorry. And we had this traditional Matillion architecture, which nobody knew what exactly this Matillion architecture was doing. It's mostly for the data lake. BigQuery is for warehouse, right? So there was a mismatch between what was thought and what people were doing. So over the period of time, what we did was to come up with a better architecture with the modern data stacks. We felt like, okay, these stacks, we have a knowledge, we have a people to do it. Why not have it? Nothing great over here. Everything you would be also doing in your organization, but just a recap here is that we have an Airflow, we have self-hosted DBT, which means it runs on the Airflow. And then to get rid of Matillion, we wanted some tool, and we cannot get rid of Matillion very quickly, right? Matillion was so infused in our blood that it was almost impossible to get rid of it. Just a quick fact, we get rid of Matillion 3 months back. So imagine from 2021 to 2024, it took us like 3 years to get rid of it. So now we have a Fivetran, which we have placed our operational sources. We felt like, okay, let the load on engineers be offloaded to automated or managed solutions. So we focus on more good thing. This is where our choice was Fivetran, and then we have a couple of things on in-house. So this decision on house was based on the fact that Fivetran does not sign a contract with you if you do not have X amount of money to be spent on them yearly. So it was way hard for us to sign something with them or onboard the data with them. For example, Bongo HR or Greenhouse, and mess with data there. So we didn't go with that, and we built this in-house stuff. We also onboarded data observability, Monte Carlo, Elementary, which finds well, and Looker, Tableau onboarded already. So this architecture was fine for us. But this is not the end, the journey starts from here. And this is where I would like to present you the next fact is what I think Matthias was speaking about, right? Automaticity. So this is also with us. We also felt that we didn't have any control on Fivetran or Matillion tool to do customization. And this is where we were becoming excessively dependent on in this scope is Fivetran, but before it we were excessively dependent on Medallion. One of the examples which I would like to share is MongoDB driver, right? So there was an instance, also like we were disconnected from backend engineering or platform engineering. So they upgraded the MongoDB from version 6 to 7, and our job started failing because the vendors which we signed up for, they haven't upgraded to latest version of MongoDB. Well, it was a weird situation for us, but a great learning that excessive dependencies here would lead it to a situation where our platform would be down for 1 week of time. So we have to hurriedly do the stuff to find a workaround solution so that we can bring it up. The other thing is obvious, right? If you put all the central control into one tool, you are going to face with difficulties. So what drives warehouse is not just operational data, the non-operational data as well, right? If you start putting your non-operational data also on managed solution, and if it goes down, you have a 0% of things running in your warehouse, which means total downtime, no reports running, no refresh happening. So this central control is also a problem there. Together, this excessive dependencies would create lack of autonomy, and we love autonomy. We love engineers to build this stuff, to innovate this stuff. This was against our values, which I've shown earlier. This also leads to the developer frustrations. Okay, I've shown you a diagram where we built a lot of in-house stuff, right? Imagine we have 4 engineers, right? 4 engineers have 4 different ways of building this script. ETL is just like a notion of how to build this stuff, but it does not speak about you should not do or you should do the stuff in this way. So engineers are free to build the way they like it. They don't have any guidance, and this is where the point of switching context comes into picture. Now, every engineers build their own scripts, and if I have to learn his way of programming, I have to learn what the script is doing. So it puts like cognitive load on engineers. So the morning engineers come to the office, he will be always burned out by the fact he knows that he has to learn something new. So this was the thing which we were facing. And the other thing was poor observability. Wherever you go, I mean, as of now, today, Fivetran does not have better observability than what you can build yourself. This is my experience working with Fivetran. So we still deal with, we have a couple of operational data sources on Fivetran, and we struggle every day with nitty-gritty details of observability. So where does this lead to? This lead to to a point where we have to categorize and work by picking one operation system on which your whole company is dependent on. In our case, 60% of all the operational data or the meaningful data comes from the MongoDB, because backend is our MongoDB. If MongoDB is not running, we simply say 40% is not running. No, we don't say that. We say that nothing is working in the warehouse. So that is the importance of ingesting via MongoDB onto our warehouse solution. Having said this, this becomes a crucial point, and this becomes a heart of our platform, where we have to be wary of that this pipeline is running and continuously delivering data to the warehouse, and users are using them. But it is not filled with challenges. The challenges which we have seen with the MongoDB, before that, this is not a self-hosted MongoDB, it is hosted on Atlas. So the challenges also comes from the platform where it is also hosted. Every company loves to know more minute details of their data. The second point here is limitations on detailed change logs. So Atlas have limitations there. You cannot hook more than 2 connections, 2 change streams. And this put limitations on us to know what is the data which is changing in the Mongo, or how frequently the data is getting updated, or which data is getting deleted. So there is a limitations on us. The second thing is performance bottlenecks. If you have worked with a backend engineering team, you might have seen that they might have created a bad data model with bad indexes, and you might face difficulties in ingesting those data. One of the example which I faced was our job was running for 48 hours simply because index which was created on that table was wrong or not performant. And this led to us wondering, I mean, what we could do as engineers to fix this, Um, also, whoever are from the data team, we would hate changing schemas, right? Anyone changes schemas, you would have been very frustrated. I mean, with the MongoDB is that thing, So MongoDB is NoSQL databases, so people are free to add the column or remove the column as they like. This sounds good for the engineer, right? Backend engineer for the feature, but not for the data team. So this is one of the crucial challenge which we have faced. And if I have to list the top one out of these four issues, I would say the changing schema was the most frequent problem which we faced every hour in our work life. Um, so flexibility which is given to the engineers turns out boon for the backend, but curse for data engineers. And this is where we struggle with the data quality of overall data. So someone adding a column, fine. Someone removing the column, fine. But that reflection on the data warehouse would look something which we not desired for. Also, bad practices which backend engineers infuse. So someone have a string column and they change it to boolean. It's easy for them to do it. Yes, it's possible. But for us, on the warehouse level, right, where the schemas are static, it possesses us a challenge, like which data type should we choose for. We understood that data quality is not our problem to solve. The data quality problem is to be solved by the producers or by the backend engineering team. The ownership solves that problem. And this is where we built an event ETL architecture where, as you can see, it has multiple components, but data producers, they are the one who drives this. So we share contracts with them. Contracts are nothing but the schemas and what to do and what not to do. We have also onboarded schema registry topic where they can set the messages. And producers, they first they create the schema of whatever the model they want to send the data for with the contracts which we have shared with them, and then they emit the messages onto the topic. Good thing with the Google is they have built the BigQuery subscription, which reads from the PubSub and then writes directly into your BigQuery. And overall, this is like open source solution which we have done. What we have done is a schema transformer here to automate our tasks. So schema transformer is the tool which reacts to the events which happens in the schema registry and goes and does two things. It cleans up the data. And then it also normalizes the data, which comes from the source, apart from creating table and stuff like this. So all this information is then sent over the metadata to the raw, to the DBT, even to the DBT, and DBT processes into the station. So we have centralized processing tool called DBT, and we don't go out of it to build another pipeline. But this is where our event ETL architecture works fine. This works fine for us. But this whole architecture also has a challenge, right? Developers have to build the schemas. They have to be taught about the contracts. They have to follow strict guideline. We have almost automated all of this stuff. So the framework which you see over here, right? So written in TypeScript for us, given as a package, and developers just have to write on top of it some interfaces, and the data is produced. But even there are the chances of errors. And nevertheless, having schema registry, schema transformer running, raw data coming over there, this has to be a use case driven solution. I mean, there should be use case for this one. We cannot simply blindly copy for 200 of collections the same pipeline, right? And this is where we came up with difference or a rule say like when to use this event and when to use batch system. So we use events when the schema is highly complicated. The complexity here means that developers tend to do a lot of updates or deletes on top of those schemas, and and then we need track and audit data. So you might have heard about SCD type 1, type 2. So if it is required by our consumers, you tend to go with event. And deletes, of course, since we cannot go for Debizium-like tools or CDC-related tools. This is also a nice tool for us to track those changes. However, we choose batch ingestion when we have less complicated schemas, and we want to do a fast onboarding of the data for our users for experimentations. Not every table which is there in a warehouse is used for the analytics, right? Some do experimentation on top of it. I cannot set up this whole flow, like event detailed flow, for just experimentations. For experimentations, I need faster onboarding, faster offboarding. I need flexibility there. I don't have to sit and fix every data issues which is there in the MongoDB database. I need to have a generalized script running for it, and also customizations, which I will talk about it later on. So with this clear difference between event and the batch, we went into the market and we started searching for the tool which can do this stuff. Of course, we were ready also to build it, but these were our success criteria to say, okay, what can make a pure batch ingestion pipeline successful? These were our success criteria. And this success criteria was perfect for the DLT. DLT fit well on all of them, and this is where our new architecture would look like this. Now we have uploaded MongoDB, and now MongoDB run as part of DLT. Rest apart, the architecture stays same. We have grown over the time, so you see a lot of reverse ETL. Whatever diagrams which I've shown here, right? These are like handfuls of them, but we have tremendous amount of sources and also a lot of reverse ETL which we do from the data platform. Nevertheless, how did we set up DLT in Forto? So these are the bullet points. Our DLT runs on a function. It is YAML first. We don't write pipelines every day. We just configure them in the YAML. And we have a framework or sort of like integrator, parser, which reads all this YAML file and translates it into the Airflow job. This makes us faster so that or self-service for our users. They don't have to rely on us to onboard a collection. They can simply go and add YAML and it will be picked up by our jobs. There are three modes which we have configured: full, incremental, full chunk. I think full and incremental are self-explanatory. Full chunk is something for a large collections in the MongoDB, which you do not want to ingest in one single process. So what we have done there is to have based on certain configurations, divide into the chunks and ingest so that pipeline does in a faster way. Fourth point is developer friendly. Our developers are not burned out. Now they are happy because everyone knows that what pipeline like how to build the pipeline. So they have to use DLT good practices and they have to build. So our developers are not burned out. They are happy about this. Just to show you a diagram, this is how our YAML configurations look like. Just the collection, the load type. If it is incremental, then we give a timestamp column. If it is a full chunk, we give the chunk size and certain configurations which are essential for that to create the jobs. So YAML is created by the line parser. It creates the task. Each task executes the cloud function, and all the development process we have from the GitHub. So all the CI/CD for the DLT on which we have built extended code runs separately. Integration test, unit test, they all run separately so that our DLT development is separate from Airflow development. So this is how it runs. This is one of the examples, and not just like I've shown you the very overview detail about all this, but as I said, like customization is the key here, and we're happy also to say that we have done so much of customization that these are tasks which can't be put it on the screen, but we have like monitoring tasks which captures the stat about the jobs, whether it has ingested required amount of data from its source or not. So this has made our MongoDB ingestion, the data from operational data very strong. Uh, so a couple of facts, the value which DLT brings to the Forto. We have made a declarative pipeline which our platform needed. There are 200 collections which we onboard. It's self-service, as I said. Enhanced efficiency, zero maintenance. Yeah, there were bugs, but in single digits. I will not call it like pressure on us to say it's not running good. So we have zero maintenance there. We have set 4x cost compared to managed solution. It's a great achievement for us there. Security and compliances. Security topic was the one which data team lacked a lot. So all these traditional tools, right, Fivetran or Matalin, they work on a password. You give username and password. But our company had a policy, not policy, but let's say let's use the word policy to get rid of those user credentials because they can harm the Forto in the big way. Number of database which we onboard are around 40. So imagine 40 username and passwords. It's very hard to manage, So we have this passwordless auth with MongoDB, and if I have to use any other tool, it's not possible there, where I can set up this thing. So with security and compliance, DLT shines there. So we have now passwordless auth as well. So all the green sides, right? I just want to share a couple of challenges while working with DLT also. We feel that there is a slow execution when deployed on a cloud functions. Basically, the way we have seen is, or partially because of second point there, that DLT holds all the records into the memory and then runs the normalizer step. So possibly this creates a bottleneck on execution. So it takes longer amount of time to run a cloud function. Although it's not that longer that we have to wait for 24 hours for sure, or hour in this case, but it could be a faster. There's limited number of connectors available. Sources here. So yes, we have to build, not a pain point, but still, if it have been available already, it saves a lot of development time for us, right? The last 2 points are not the challenges, but just like an improvement points. You see, we are using schema registry, right? It brings benefit. Schema registry also is for knowing what schema has been published by which users, and this helps in knowing the stuff, like for data catalog stuff. It helps there. I know DLT spits out the schema files. It would be also nice if there was an integration with the schema registry so that we get benefited and we don't have to build those integrations. I know monitors are also there, but think of it this way, that we use Datadog a lot. Right? If it had been the pre-built monitors, it would have been a nice tool just to onboard and use it. So we still have to build monitors, but again, we don't see as a challenge there. It's just the improvement and can be customized as well. So thank you so much for listening to me. That's all.